Welcome to our channel ClassFly community. So today we will be doing the video on the three-phase induction motor. So let's begin. So we know that this is our three-phase induction motor, right? So here we know that it has two components. One is stator and another is rotor. We have already discussed in the previous video. So the stator is the stationary part and the rotor is the rotatory part. And the most important thing is that the three-phase supply is given to the stator and it doesn't have any motion. And the rotor has only the rotating facility, but it doesn't have the three-phase supply. Okay? So see, here are the components arrangement. So just I am showing you the main part, that the rotator is above the shaft. That means it is above as a layer the shaft, and this is our stator part. Okay. So let's move on to the slip, which is the most important part of an induction motor. Before that, always remember that that the induction motor is an asynchronous speed. That means it is also known as asynchronous speed. That means that we know that a stator is stationary, right? This stator is stationary, but its magnetic field is moving. That means its magnetic field is in motion. So that magnetic field is the synchronous speed. That speed of the magnetic field is a synchronous speed. And the rotating speed, we can say, that means this is the rotor speed, will be a rotating speed. So why it is said asynchronous speed? Because in the induction motor, a rotating speed must always be less than rotating speed must always be less than our synchronous speed. Okay, so we will see this concept in a slip. Okay, so let's move on to that. So here it says that the rotor speed is different of an induction motor is different from the speed of the rotating magnetic field. Don't get tense that what is the speed of the rotating magnetic field. It basically states that it is the synchronous speed. So the rotating speed must always be different from the synchronous speed. Okay, and the difference between the speed will be our slip. And here this ns is representing your synchronous speed, and this n is representing your mechanical speed of the rotor. So what is a synchronous speed? Can you tell me? I already told that stator is stationary. Your stator is stationary, but its magnetic field has some motion. So that is why that speed of that rotating magnetic field is the synchronous speed. Okay. So we can say that the difference between the synchronous speed minus the rotor speed is our slip speed. That means your numerator here will be your slip speed, and the down part is your what? Synchronous speed. This one is your synchronous speed, right? So we can also see that the slip is the ratio between the slip speed by our synchronous speed. Okay, so for the percentage of the slip, what we do, we just do a multiplication with 100 and we get a slip speed. Similarly, if we do the ratio percentage of the slip speed by the synchronous speed, we can get that also a percentage. So let's brief this point again, that our ns here is our synchronous speed and our nr is our what? Mechanical speed of the rotor, or you can say the rotating speed. And always remember that the synchronous speed is that a stator is stationary but a magnetic field is rotating. So that is the speed of the rotating magnetic field is the synchronous speed, and the rotating speed is the speed of the rotor. Okay, so can you see now when our slip will be maximum or minimum? See, the equation is our ns minus n, that is a rotator speed, n by ns, right? So if I do that, if I put n is equal to 0, then what will it be? It will be ns minus 0 by ns. And when we solve this part, we get what? We get ns by ns. So, and when we solve this, we get is equal to 1. That means whenever our nr is equal to 0, at that point we will get a slip is equal to 1, and that means that will be a maximum slip. So it states that if the rotor runs at synchronous speed, s is equal to 0. If the rotor is stationary, s is equal to 1. The second statement, if the rotor is stationary, that means when our nr is equal to 0, if our nr is equal to 0, that means our rotor is stationary. Okay. So at that point of time, our slip will be maximum. Whereas when our nr will be equal to our ns, that is a synchronous speed, at that point of time it will be ns minus ns by ns. So we will get s. So we will get what? We will get s is equal to 0. That means if the rotor runs at synchronous speed, we will get our s is equal to 0, and we don't want that. We don't want that a slip to be 0, because we know that our torque is proportional to a slip. So if a slip will be 0, we will not get a torque, right? So we will always do that. We will have our nr less than ns always, and never it will be equal to 0. That means, never it will be equal to ns. That means we don't want a rotor to run at synchronous speed. If it will move at synchronous speed, it will make our slip equal to 0, which we do not want. So always remember this point. And another thing, can you tell me the range of the slip? Yes, you are correct. The range will be our minimum to our maximum. Okay, so it will be 0 less than s less than 1. This is our range for this slip. Now can you tell me, well, our slip can be negative. That means then our nr will be more, then only a slip can be negative, right? Yes, our slip can be negative. That means our nr have to be greater than the synchronous speed. That means it is violating our assumption that our nr need to be less than ns, that is it need to be a synchronous speed, but it is becoming greater than ns. That means it will start generating the generating action. that means it will start behaving like a generator. So we don't want that. That's why it can be negative slip, but it will act as a generator instead of a motor. Okay, so I hope you understood what is slip and how we need to bring out the slip percentage. Now we should know that the significance of slip and the advantages. So see, here we can see a circuit connection, right? So this is, we know that in three-phase supply, one will be a red color, one will be your yellow color, and one will be your blue color. So your red color will be connected to the red portion, and the yellow will get connected to the yellow, and the blue will get connected to the blue. And remember that mainly the rotator wing is always in the star connection. And what I told, if you get a inverse of your Y, that means it is a star connection. So you can see all the slip rings are connected to each other with the lines. And there is an external star which is connected, that means there is a rheostat which is connected to all the slips, right? That means to all the supplies. So this is basically the circuit for the slip ring three-phase induction motor. And now we will do the advantages of slip ring. So it has a high starting torque. So it will always have a high starting torque, but it will always have a low starting current. That means it will have a high starting torque. It will have a high starting torque, but it will have a current will be low. Okay, and next it says that possibility of adding additional resistance to control speed. So if we want to control our speed, we can have an additional resistance. Okay, so these are the two advantages of slip ring induction motor. And the application, because as it has very high starting torque, so we can use it in hoist, cranes and elevators or etc. So as it has high starting torque, we can use it at the hoist, cranes and elevators or etc. So I hope you understood the slip and the significance of the slip of the three-phase induction motor. So today's lecture ends here. Till then, be happy and have a great day.
Now is the quote time. Hide yourself in God. So when a man wants to find you, he will have to go there first. I hope you understood the lecture of today, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.